The most common question I get about 3Blue1Brown is, what do I use to animate the videos? And the short answer is that I wrote a custom Python library. Its name is Manum. So it's all programmatic and it's also very bespoke. And what I wanted to do with this video is offer kind of a behind the scenes to show you, one, what Manum is for those who don't know, and even for those who do know, to show a little bit about how I use it and what the workflow is. Now, the way I'm doing this is I sat down with Ben Sparks when I was in the UK a couple months ago. Many of you may recognize him from his many great Numberphile videos. He wanted to know how Manum worked. I knew a number of other people had that same question. So I recorded the conversation. It's kind of a scrappy recording, but we'll make do. And after a simple hello world example, we animate the famous Lorenz attractor, which is very important in the foundations of chaos. It's also just a fun visual to get into. One quick thing I should mention before we dive in is that there are actually two versions of Manum. So the first has a history very intertwined with the history of the channel. The way I started the project, basically when I was finishing my undergrad, was that I wanted this coding project that would somehow let me illustrate mathematical functions better as transformations. Made a super scrappy bit of Python code for that, used it to make the first video on this channel. As I made more videos, the tool improved. As the tool improved, I would make more videos. And that's just continued ever since. Like the most recent video I made, which was about holograms, if I do say so myself, I was pretty proud of the visuals in that. And that would have been dramatically harder to do even 2 or 3 years ago. But over the last month, it was actually kind of a joy to make just because of a lot of the workflow improvements over the years. I've always posted all of the code that I make for videos. It's openly visible on GitHub. And I also made the tool itself, the underlying tool Manum, open source. But I don't, as a personality type, really have the constitution to manage an open source project. I also don't really have the capacity for it while I'm making videos. So I wasn't the most attentive to issues and pull requests and things like that. But a community of people who wanted it to be a more robust tool for others forked the repo and created a version that is attentive to issues and pull requests and has better testing and better documentation. And it's called the Manum Community version. So it's generally recommended people start with that. But in the meantime, I often do make a bunch of changes or developments to my own. Over the last couple of years, I've made it more interactive, more performant, things like that. The reason I bring this up is that what I'll be demoing with Ben is my own version, but you should be aware that there is this divide and that if you want the better documented and tested version, it's recommended to go with the community one for that. Without further ado, let's dive into the Hello World example.
It's all in Python.
Okay, and on the left is a Python, just a text file essentially with...
Yeah, so it's Sublime Text. I use Sublime, that's a text editor. We're going to be typing some Python here. I guess just as like a basic sense of what it even looks like to have something up on the screen. Let me get something there and then we can talk through what's going on. Here,
boom.
I've created a scene. So all of the scenes that I edit together take the form of a class in Python. And then inside a certain method of that called construct, this is where all the code that renders stuff is going to live. There's objects added like a circle.
Like you just know.
We can add like a square in there too. We're also going to add that square. If I kind of ran all of that, we have the square.
How did you just run that? Was there...
Oh, yeah, okay. So this is what...
I think you just waved the magic wand and it happened, right? But you have a shortcut, it looked like.
Okay, so... in principle, if over in this little terminal, it's a Python terminal such that we can call commands on the scene that are relevant. So I might say square.shift to the right, and then that square will shift to the right. And if I call that again, more things will happen.
Okay.
I could also say, what's 1 + 2? Just normal Python.
Okay, it's a Python just entry box, basically, yeah.
Yeah.
But it's talking to this.
And so while I'm creating a scene, it's nice to have a Python terminal that's talking to the scene itself. And then separately, so what might be nice as a workflow is to say, hey, I've got all this stuff that I'm going to do. Like maybe I want to take square and I'm going to put it to the top edge, right? And so a common thing that you might do is say, take that, copy that, go over to this, paste that, press enter, right?
And that immediately tests that line.
Exactly. So then it tests that line. But I don't want to do that every time. I don't want to like do it and copy and paste. So instead I have a shortcut written, and this is tied to some Sublime specific things. In my case, it's Command R is I think the keyboard shortcut I have. It'll copy it and it'll run whatever the text that was copied in there.
So you've got a shortcut which runs this code.
Yeah.
Outputs the visual.
Yeah.
Immediate check.
I just want to jump in with a quick comment here because there's slightly more going on under the hood. Like all things, this is best motivated with an example. So if I pull up a scene from the most recent video on holograms, these can get quite long. So here, This is, the final output was a 4.5-minute MP4 file describing diffraction gratings, and in particular, this one was about the double slit. It's really nice to have these long scenes because they share a bunch of context, and as you're coding, you can kind of reference that context. But the code for something like that ends up being just a big pile of Python. Lots and lots of code. And it used to be the case I would break this all down into little subroutines, but historically it's proven to be nicest just to have it kind of all in one spot where all your local variables are shared. The thing I want to highlight is that if I'm working on this scene and I'm somewhere in the middle of it, so lots and lots of code has taken place, but we're, in the middle at this point, while I'm iterating on just one little section, like here I might want to be able to run the code of this section and see what it does. As you can imagine, you might want to tweak it, you might want to change it a little bit. So in this case, let's see what's going on. We've got some graphs being drawn. This like wave kind of showing the red and blue wave is fading out a little bit. So maybe I could say, what if I don't want it to fade out as much? I want that to only be 0.8. I want the runtime here to be a little different. I want to be able to run that same section, but in order for that to work, when I'm pasting it in, it can't just literally be pasting the code. It has to revert to the state that the scene had at the start. So it's really running this little thing called checkpoint paste, which basically says if the thing that was copied starts with a certain comment, I'm going to see if I've seen that comment before and cached a state of the scene associated with that so that I can run it. Basically, it's making it behave a little bit more like a notebook, like a Jupyter notebook. Some viewers might be wondering why I don't just have it all in a Jupyter notebook. But I really like having the scene in a single text file and being able to interact with it through scripts and things like that. But this is kind of like a hybridization between just the raw text file and a notebook itself.
We could also have some like text on there that maybe literally says hello world.
That sounds like a good plan for a hello world function.
Yeah, put that to the top. And that's also something, it's not going to show up on this if we don't have this line.
So the adding makes it appear, but and it looks like, so this is me naively thinking, when you make an object, it puts it in the middle, and unless you then do some edges or some other movements, it moves it around.
Most objects default to being in the center.
Okay.
Instead of adding it, a different thing you could do, anytime you're going to do some kind of animation, there's a method called play, and then instead of throwing in an object, I'll say there's something I want to do to that object. So in this case, maybe I want to write it. So make it look like it's being written on the screen.
And there's a function baked in here. That lets you, nice.
And I could have some parameters. I'm like, hey, maybe I want that to happen a little bit longer, like with a runtime of 3.
Okay, and suddenly anyone who's watched any Manim videos recognizes that effect. Yeah. It's there ready to go, and that's really useful.
Like I wrote that effect, and like nothing else uses that particular effect of having the like edge come on and then fade in the right way. So that's the signature look for it. A different philosophy also with Manim was like anything can transform into anything. So what I mean by that is, let's say we've got this text. I might say, hey, I want to take the H of that text, and then I'm going to make it turn into the circle. So that's going to turn into a circle.
So you defined the circle already, but you didn't add it anywhere.
Exactly.
And now you're going to transform the H into it.
Yeah, so if we go to this point, the text gets written. What this line is going to do is say, extract the H from that text, and then transform it into the circle.
And because the circle was in the middle, it has moved it. It hasn't just put it... Okay. And so these built-in functions like write and transform that we're just seeing, these are the ones that you sort of sculpted to make the jobs that you wanted to happen.
Yeah, exactly.
Nice.
Exactly. And so a lot of things derive from transform. So usually, like, it doesn't really... There's no pedagogical reason to have like an H turn into a circle.
I enjoyed it.
It looks nice, and we can maybe make it a little bit slower.
I mean, I have other questions. Like, it didn't just transform. It looked like it was eased. There's all sorts of nice smoothing functions going on.
Oh yeah, okay. So let's play with that. So let's play with the transform. So here, notice like the H is shrinking and the circle is growing. I don't actually want that. So when I extract the H, it creates a group of all of the H's that it found in this text. So if I take the first element of that, it'll have a thing. This is uglier than it needs to look. But if I want the thing that's
matrix, is it really?
It's like there's a hierarchy where you might have groups of objects. Like this whole text is a group of characters.
But within it,
so if I just want the first character, actually a simpler way to do this, it's very dumb. I'm going to take the first character. So the 0th element in that Python list. Then the actual points data of that H. Like
that's fun. Okay, right.
Yeah.
So instead of taking the character, it's just got the geometrical sort of...
Yeah. And so the smoothing there, there's an attribute I call like the rate function, and it defaults to a thing called smooth, which just looks smooth. But if
is that the classic smooth step sort of profile?
Basically, yeah, it's a cubic Bezier, I think, that'll be like a smooth step. But if it was linear, then you'll notice it's a little jerky. This will be easier if it's a runtime of 1 to see it's like jerky start, jerky stop. Sometimes you want that.
Yeah, sometimes you don't.
This will come up for us later, actually, is we'll need this to be linear when it defaults to smooth.
I'm really excited to see that because it's those details that make the difference from like, I've made something move to I've made something look good.
Yeah, exactly.
I really, making that easy to do is a big part of what Manim's doing, I think. We mentioned let's do a classic piece of sort of recreational, interesting maths that a lot of people have heard of. Yeah. And I was like, I've never plotted a Lorenz attractor, and that was why I suggested.
For those of you who don't know, the Lorenz attractor is this very bizarre shape that came up in the early history of chaos theory. Ben and I do talk more about it, but what you need to know is that it comes from a set of differential equations in 3 dimensions, which basically means if you have a point somewhere in 3D space, there's this set of deterministic rules that tells you how that point should change at a given moment in time. And what happens when you try this for a variety of starting conditions proves to be very interesting, as you'll see. It's really nice fodder for animation, and if you want to learn more about it, I'm pretty sure there's a great Veritasium video on it, but also one of my favorite books, which I think I actually should have up here. Yes, okay, so one of my favorite books by one of my favorite authors, James Glick, describes, kind of how this came about and the role that it had in early chaos theory. All of that's by the by, but some of you will want to know, so I figured I'd share.
I guess maybe one thing I should mention before we dive into this. This is all in 2D, but the points are actually all in like... Whoa, that's a bug.
That's a rendering bug, is it?
Yes, actually, okay. There's a thing I was playing around with on the low-level rendering recently. I know what's going on and why that's happening, and there's a dumb way to fix it, which is yeah, just don't worry about that.
Fun to see the back end here.
Don't worry about that. Sometimes I go and I try to make the rendering nicer, and then that messes up other things.
That was always 3-dimensional. We just happen to be looking.
Everything's always 3D. So, for example, if I add 3D axes, then it's like everything exists by default on the XY plane, and just like 99 scenes out of 100, I'm just doing it in 2D because pedagogically, you want it to feel like a blackboard. Only go up to 3D if you really need to.
Yeah.
Now we really need to. So. For the Lorenz attractor, our setup, I just have some like axes with some coordinates around what we're going to want to be in. I'll be very honest with you. The way I started here, I went to ChatGPT. What you want to do for the math underlying this is to basically feed some software a differential equation and an initial condition, and just say, how does this initial condition evolve? Obviously, people will have built software packages that do it with something smarter. So I just asked it. I'm like, hey, write me a Python function using some numerical ODE solver to find a solution of the Lorenz equations.
The famous Lorenz equations.
I just wanted to...
not the other ones.
Sometimes...
I like it.
As you've no doubt found, if you're trying to engage with some new library or something, it's just kind of a nice way to see what it is.
Yeah, it solves a lot of the protocol issues that sometimes you take 3 hours to get past.
So it's mentioning the SciPy integrate. So that's a nice library, and it's got this solve initial value problem function.
Nice.
And then it gives some boilerplate for how that would look. And it's using Matplotlib to render it. Abundantly reasonable, but we're using Manim, so just adapted that a little bit. Yeah. And so essentially, I've got a function here to describe the differential equation. It says for a given time and for a given state, which is going to have x, y, z coordinates, just what's the derivative of that state.
And you've got 3 parameters, which you've got Greek words for,
and so that, I guess if we go to the Wikipedia page for Lorenz, this is a system that has some parameters on it that I guess we can kind of freely tune.
Yep.
There's some parameters that someone must have found makes for nice diagrams.
Let's use them.
And so let's just use them. Let's keep this page open. So if we want to render the equations onto our scene to do it in that Manim way, we can do it in a moment. So we've got that. I've just got a tiny little wrapper around the SciPy numerical integration solver for us, because what I want to do is be able to say, hey, for a given initial condition, just give me all the points that are going to be the solution.
So let me just check. And you kind of need to know what it's going to spit back at you in order to interpret it. It's giving you something called solution, which is going to have time values and X, Y, and Z values.
So this library is a little weird. It's kind of like it's treating Y as the output, but Y might be like a vector value, which is a little confusing, and which is part of why I wanted a wrapper, so that I'm just thinking in terms of states rather than like its language is involving like a Y. And I also wanted this matrix transposed for how I like.
Oh, gotcha. That's what that T is. Okay, yeah.
It's just all like, don't worry about the wrapper too much. Let's just actually see what it looks like.
Yep.
So let's say our initial condition is something like, let's just make it 0, 0, 0. Why not? And then we can take the solutions where I'm passing in a given function, which we want to be the Lorentz system. I'm passing in that initial state, which is the initial state we just wrote down. How long do I want that to go? So let's see what, 10 seconds of solution looks like. And this right here is just going to be a set of points, basically. And so if I run this and I ask, what are points? It gives a bunch of zeros. This is maybe predictable that 0 is going to be a bad initial condition.
Yes.
Yeah, so let's make that like 10 or something like that. And so now if we look at the points.
Right, there's some interesting points rather than all zeros.
Yeah.
Okay.
So in this case, I could render a curve where like I said, I call everything a mobject for a mathematical object. Many of them are vectorized objects, which just tells you how it's rendering as opposed to being a surface or like a point cloud.
Yep.
And these are things like curves that have some sort of stroke, thickness, fill, and all that.
So that's interpreting the points and then drawing lines between them, essentially.
Well, so to do that, I'm basically going to say, hey,
I see. You're
set
making
your points as corners as if it was a polygon. All of those points that were just created. And then let's see what that curve looks like. If I knew how to spell self. So if I do that, we don't see it, but actually
it's up there.
It's up there. No, because the thing is, I was just adding the points, but I wasn't using the coordinate system of these axes in any way. And so...
so they're not necessarily going to plot them according to those axes.
Right. So what I actually want to do is take the axes, and there's a function called like coordinates to points, which is basically going from whatever the coordinate system of the axes are to the like Manum coordinate system. And there's an abbreviation for that because it's used a lot called chords to points. And I'll just pass that in. And I think actually it thinks of it in terms of you pass in a list of X, list of Y, list of Z's. So I'm going to do a little transposing and don't worry about it too much. But this should be in the actual coordinate system.
Can I check what that star is doing in the penultimate line on the code?
Okay. So yeah, if you have, let's say I have a tuple that's like 1, 2, 3, right? And then if I define a function that takes in like X, Y, Z, and it, returns, let's say like X plus Y plus 2 times Z. We'll do it non-trivial. If I call function on that tuple, it'll be like type error.
Because it wanted them separated.
Oh, wait, sorry. That'd give a different kind of error. It wants them separated. So I could do it like, pass in like the 0th element, pass in the first.
But
Python has a little syntactical snazziness where if you put an asterisk in front of an iterable thing, it'll unpack it for you.
This is the most useful thing I've learned all day. So
okay, yeah.
I mean, Manum's pretty good, but good. Thank you. And joking aside, that's helpful. If you don't know what that was, it's always mysterious to see things you don't understand what they're doing. But that's great.
So in this case, points is an array where I like to think of each row as one of the points, but the syntax for this chords to points is going to take in lists of the X coordinates, Y coordinates. It's maybe a dumb design as I'm thinking about it right now. Like maybe the way it should play. It makes sense. The reason it makes sense is usually when you're calling this, you have axi.c2p. You're just passing in actual individual ones. Like, hey, I want to know what point does this correspond to in the Manum coordinate system. And it's like, here's that point. Hey. So if I wanted to add a dot there, this we could see where it shows up for. Why can't I type self?
Because you're on camera.
Because I'm on camera. Yeah. And so it's putting it at that.
And you say it's a dumb system. If it works, it's not a dumb system.
Yeah.
It can always be improved, right? But it's working. That's a whole lot better than many systems we try and make.
Great. So let's have some fun with this.
Yeah.
Right? We could see how it evolves rather than just adding the curve. We could show the creation of the curve, which is basically showing the system evolve.
So that's going to take all those points, but just kind of run through them slowly.
Yeah.
Or make them appear slowly.
Well, here's what it'll do.
Right.
It'll draw it. But that was very fast. So maybe I want the runtime to match the actual time of the dynamic system. So it should draw it over the course of 10 seconds. But here it's trying to be too smart. When it draws things by default, it does that smoothing function.
I see. And that's actually changing the behavior.
Yeah. So actually we want the rate function in this case. Almost always it's nice for it to be smooth. This is one of those cases where the math that it's representing is relevant.
Needs to be kept rather than masked. Yeah.
So instead, linearly, this is the actual evolution of it.
Nice.
And so we can style it too. maybe we want to set the stroke to be, make it look blue, make it look a little bit thinner, something like that. We could actually give it like a range if we wanted to have it kind of like gradient between things, which I don't know if that looks nice or not, but you can imagine
that's starting blue and ending up red.
Yeah, starting at 0 stroke width, ending up at 10, or starting at 10, ending up at 0.
Knock yourself out.
Yeah, those look pretty ugly to me, to be honest. And also, I think we'll want to use colors for a different reason now, because the reason this system is interesting is because it's chaotic. If you have initial conditions that are really close to each other,
but not quite
the same, they start evolving the same for a while, but then they stop. So I think here's the way that I want to illustrate this. We're going to create multiple curves. I'm going to have curves which I'm going to create a group, and I call it a V group just to say, hey, these are going to be vectorized objects. That makes the rendering a little faster if it knows that. If it doesn't know that, it'll render them, but it doesn't use a certain trick to make it faster. Then I'm going to go through a bunch of states, which I need to define now. So states, I'm going to maybe make into...
And these are your initial conditions.
These are going to be the initial conditions. So let's just change that, that z coordinate by a little bit. So we'll take like an epsilon to be like 1/1000th. Maybe I'll make it more explicit for n in range. I don't know, how many initial conditions do you want?
Should we start with just 2?
Sure. Yeah.
I mean, I know you're doing a whole list for it, and that's slightly redundant, but
no,
then we
can
crank that up to lots.
Yeah, this will be good. So that'll be our state. So these are not going to be dependent on the state 0, but whatever state is part of our for loop here.
Yeah.
I'm going to take everything we just did and basically say...
Put it in the loop.
Okay, points were just created. Great. Okay, it says blue. I don't want them all to be blue, so let me make some colors, which at the moment, because there's just 2 right now, we're going to have to change this in a moment, but I'm going to make it blue and red. But like...
You eventually will need some numerical way of changing it.
Generalized, yeah. But this will make it kind of easy to see now.
Commenting program.
Oh, it's a rarity when I'm animating.
Someone's watching now, eh?
Yeah. I'm not the worst in the world, but there's a lot of room for improvement. So I'm just going to include that in the loop. So I'm zipping together the states and the colors, and so the curves are going to be colored differently. And now this showing creation, I want to actually happen. Here we'll use our star again. I love list constructors and all that. So here's a little fanciness for what we're doing. So we've got this group of curves that actually, in this for loop, I'm going to need to add each one. So curves.add curve. So creates an empty group. This list adds new curves to it. Yeah. In this case, there's just 2. In a moment, we can make it 10 if we want. And then this is going to create basically a list. It's a generator, but it'll create a list of animations. Those animations are this show creation thing. And then the stars, so that as you pass it into the play argument, it's passing them as if they were multiple different animations. So there's a little bit baked into that. But essentially what we want is that we're going to have an evolution of 2 curves at once. And right now you only see the red one because the red one's being rendered on top of it.
Yeah, but now they've diverged.
Now they've diverged. I want to see that divergence a little bit more clearly.
We need to run it for longer.
Okay, so first let's run it for longer.
Yeah.
So let's actually name this. Let's call it, I don't know, evolution time. We could just call it time, but... And that, let's make it...
Overused name again, isn't it? Yeah.
Let's make that 30. The other thing I want to do is have little dots indicating the endpoint.
So you can eyeball it easily.
Yeah, so the way I'm going to do that is I'm going to make a group that'll have a thing called a glow dot, color for color and colors. And
again, glow dot is a baked-in function that you've got because you want often to have a point that moves and has a nice bit of coloring into it.
And so this one's not a vectorized thing. So rather than, it's just like, its data is described by a point in space and like how much I want it to like ambiently glow. And it's got a little color. And I'm going to create an updater function for it where I'm going to update the dots. This is going to be a function that takes those dots in. And I'm just going to write this function kind of in place. I often like to do that where it's like everything relevant to this animation we're doing just sits in that commenting bit. I'm going to say for dot curve in zipping together the dots with the curves. I want each dot to move to the end point of the curve. So move to curve.getEnd. So curve.getEnd will tell you its last point. The dot's going to move to that point. And this is something I want to happen on every iteration. So I'm going to say add as an updater this. This is a thing I want to be called on this these dots at every iteration from here on forward.
Python question?
Yeah.
The zip command is sort of stacking two lists sort of in parallel so that you can iterate through them in parallel.
Yeah. Okay. So let's say we have list 1 looks like 1, 2, 3. List 2 looks like, you know, A, B, C.
Yeah.
Oh, that's going to kill me.
Oh, you couldn't leave it.
So if you say for number letter in zip, list 1, list 2, print number and letter, then
it pairs them up. Basically.
Yeah, it pairs them up.
So you can keep lists which are referring to similar things sort of implicitly because of their position.
Yeah.
Lovely.
Yeah.
I mean, that's what I thought, but it's nice to see that.
And so it's unsettling in my mind right now because we're zipping things together that might not have the same size. So we're going to want to do something that makes sure the colors, in fact, let's just do it now.
Would it cope if you did, or would it spit out an error?
Well, so what it'll do, here's what'll happen. Suppose that list 1 was actually range much longer.
Yeah.
So list 1 looks like this. If we run that little bit we had above, it goes until one of the lists runs out.
Then it just
so it would cope, but you would be missing many of them.
And actually quite hard to find that bug if you hadn't spotted
it.
Yeah,
no, it is. It's why it's unsettling, unless you're like sort of fluent with Python. So I have a thing called color gradient that will basically go between two colors, and you tell it
how many steps to take.
How many steps, exactly. And so the number of steps should be the length of the states in this case. So we should just feel like, okay, no matter what, the number of colors matches the length of the states. And now I feel more comfortable.
Settled.
Yeah.
I wonder how much it is insightful to watch someone doing a workflow and to note when discomfort kicks in. That's a really insightful thing to realize what matters from bitter experience, right?
I mean, this isn't that bitter. It's maybe just like aesthetically.
But experience tells you when to worry about something, when not to worry about it. And yeah, it's just nice to see that that's how you know, I should deal with that before I forget about it.
Yeah. So how do we want to do this? Oh, yeah. So we've got our dots. We've got the updater. That means if we add the dots to the scene, then as these evolve and their endpoint changes based on what's being done,
track it around.
It should. I'm going to put in a small line that anyone who knows Python is going to vomit at. And if you want, I can explain the line and why I would never do it in any sort of like serious code, but it is an annoying necessity.
Let's see it first, and then I'll ask you. We can edit if we need to.
Must be a string or real number. What line is this coming up for? So when I set the points...
Color and colors. The color gradient is producing...
Oh. So glow.... So the initial argument for glow.dot is the center, like where it is in space. So it was a type
You're telling
error.
it you needed that parameter to be the color.
Error, which there could be certainly a better type error message, such that rather than this is kicking off to... This is where people are like, who know Python, like, the constructor of glow.dot should definitely have had better error messaging.
I'm not going to hold it against you.
Yeah.
There's the dot. And again, red's on top of blue at first ever get, and they separate.
Yeah. This is... Okay, the reason that they're running so fast is because the runtime of this is now different from the evolution time. So we should maybe have the...
So the 30 length solution is now happening in 10 seconds.
Yeah. So let's run that again, but where we... So this is in the time that it's actually supposed to be. So they start off together.
And here's the classic. They're so close together to start with, but now they're separated.
And then after a little bit, it's as if they're doing completely different things.
I want to jump in here real quick to explain that globals.update locals line, because it is such a ridiculously cursed line of code, but it has to do with a bug in the sort of IPython embed being used. So let me just show you what's going on here. Taking a super simple example, let's say I have this snippet of Python where I define some variable x. Let me make this a bit bigger. And then I define this function of y that's going to use that x. So it's defined outside of the function, but it's making use of that x. And then we're going to test, what is like f of 10. So you expect it to return 13. And it'll do this. If I run this as just a Python script, I run it from the terminal, Python of that thing, it prints out for us f of 10 is equal to 13. All is well and good. Now, inside that sort of IPython embed that's being used for Manim, if I take exactly the same code, it behaves differently, where it says name error, name x is not defined. Because I think what's happening is that when inside an IPython cell like this, it defines a new function, it doesn't necessarily share the same scope that it would in a normal Python environment. The catch-all hack for how to get around this is to say, hey, I want x to be a global variable. In fact, to just have a universal catch-all, I'm going to take the whole dictionary of global variables, which Python just gives you access to for some reason, and I'm going to say, hey, look at the dictionary of all local variables that's going to include that x. I just want everything that's local to become global, which is obviously a horrifying thing to do if this was like code for a real library or something. But because we're just scrappily running it in this little interactive session purely for the purpose of scene development, you know, it's not as dangerous. But if you were wondering, or if you were vomiting at the screen, that's basically what's going on. It's that with this kind of interactive mode. Interestingly, it's not the case that that'll be a problem in just IPython if you run that from the terminal. Like if I take this code not using the dumb hack, it works just fine. So it has something to do with this notion of embedding such that we're dropping into the middle of a scene, kind of like it's a debugger. If I'm missing someone, if someone knows like a better way to get around that, I'm all ears. Future me here. Worth being clear about one thing here, which is that the better way to do this, if you have some function referencing some variable that it needs to use, is to just make that very explicit. So in this case, I could say x is an argument of the function, give it a default value, which is the x kind of defined in the same scope as where the function is defined, and then everything will work dandy and as you want. So in the scene that I was doing with Ben, if we look over at the very cursed line here, the better way to do that, where it wants to reference curves, is to basically say, hey, curves should actually be something explicit in there, maybe an argument that defaults to the value that's going to be whatever it was on the outside. That will totally handle it. The reason I was in the habit of doing this, for one thing, it's maybe a little annoying to do that with lambdas on the fly and things like that. But the same bug would come up with list constructors. So if I was to define something like x plus y for y in range, I don't know, 10, something like that, and I want to see what this looks like. This is something where, in normal Python, this x would be visible outside. And so if we were to actually run this little test, it would do what we want. Whereas inside the Manim environment, at least previously, so if I do all this and then I ran that code, previously that same bug would emerge. But when I was just looking at it now, it seems like actually it's fine. Whatever bug had been there that affected list constructors and things like that, it's fine. So maybe I should just get out of the habit of typing that incredibly cursed line and you can ignore the last 5 minutes. Anyway, back to actually finishing out that scene with Ben.
Let's make those dots bigger. Going to give them radius 1. I don't like red as the second color. I just think that looks kind of ugly. Okay, that's a very big dot.
Yeah, it's nice.
But I guess, I don't know, we see it. Yeah, we see it. That's maybe a little bit too big, so I might ease off on that.
Again, I mean, it's a minor comment, but the aesthetics are handled for you. The glow dot, it's too big, right? But it still looks nice, even though it's big, because you've paid attention to making a glow dot function, which makes a nice looking dot.
Yeah.
So this is something I was going to ask about. This is interactive.
Yeah.
And that wasn't obvious until you moved the axes.
No, it's because everything is ultimately rendered and just like made into a YouTube video. And every now and then I've done something where I'll like have an animation I want to play with in the moment. But like, I don't know, it's not that common. So, okay, a very common thing I might do. We've got this animation. It's rendering all these. It would be nice for the camera to slowly pan throughout.
Agreed.
And so
it's amazing how useful that is for 3D rendering, is that if you're looking at a 2D screen, you need the illusion created by the rotation to keep the depth alive.
Yeah. So here's what I might do. I have another keyboard shortcut that is not documented anywhere, where I can save to my clipboard basically a call that needs to be made to put the camera in the current position.
So that's just grabbed where the camera angle is right now. That's helpful.
And so if in my animation I take the camera frame, which is like frame, I haven't talked about this dot animate thing yet, but basically I say, I want you to do this thing. I don't want you to just do it to the object. I want you to animate that over time.
Okay.
And there's some little bit of magic that underlies what's going on there. But in this case, the thing I want it to animate is reorienting itself to a certain position. So over the course of the animation, it should like slowly pan itself over.
So it'll take wherever it is, like wherever it thinks it is already, and try and get to that.
Yeah. So I'm gonna also, it's nice if the runtime as an argument of the play method, then it becomes the runtime for every animation in that method. So this might not be enough movement actually. I might want to like really have it spin around because it's happening over 30 seconds. So back to the beginning. Do all this. Is it panning? Oh, it's very slow.
Oh, it looks like it was smooth, so it might have started.
Smooth. Yeah, it's smooth. Which
not necessarily
actually,
bad thing,
I think I like that. I think I like it as a smooth thing.
Agreed. It might look kind of a jerky start if it wasn't.
Yeah, and so now it's like as we're going, we can see it from all the different angles. I think the color scheme is still a little jarring to me. So I think what I might do is make it go to teal or something that's nice and close to it. And then maybe we'll make this actually an even more aggressive
I'm not your best color audience. My color vision deficiency definitely... I don't know if my colors are the same as everyone's. Well, anyway, but yellow and blue I can see apart. Blue and teal.
In this case, like... Either you want them to be starkly different so you see it, or you want it to be aesthetically nice where maybe you're just using the shade of it rather than the hue to distinguish. So that, I mean, one thing we could try, it's going to look cleaner but maybe be harder to discern. Let's say we go between two different shades of blue, and I'm gonna, now let's have some fun and let's have there be like 10 points.
Great. And so they're just going to change by their epsilon in the third coordinate. It
doesn't
really matter. We know actually, I mean, mathematical comment. The other amazing thing about this is that wherever you start, it goes into this sort of shape. That's kind of like the second surprising thing, isn't it? Like,
yeah. The whole point is not just that it does something strange, but that there is an attractor.
Yeah.
So often with differential equations, it might be attracted to a single point.
Yeah.
It might blow up to infinity. It might be attracted to a cycle. But then this is what's called a strange attractor, where all the points are attracted to a certain shape, but that shape isn't so simple as a cycle, and it's got a fractal nature to it.
I often feel like it's the sort of contradiction inherent in trying to describe chaos to someone, because when you say, oh, chaos is when it's unpredictable, and yet at the same time it is predictable, and there's this strange attractor. So it's the fact that both are happening.
Yeah.
And this
you know that it's going to be on this subset of R3. It's gonna get really close to that subset. Where on that will it be? Well, we just had 10 starting conditions that were really close to each other. And if we remove, the curves and just see the dots.
They're all over the place, yeah.
Oh, actually, let's do this. Let's have some fun. What if the curves...
sort of fade out over...
Oh, yeah, let's have them fade out.
Sorry, you had an idea that
No, let's do that. Let's have the curves fade over time. I want to know what your idea was. How do I want to do that? I'm going to...
I definitely made the part that follows with bin way more complicated than it needed to be. We also got sidetracked chasing down a couple different bugs. I think what I'll do is post the full, relatively uncut version of that conversation, maybe on Patreon, but just give you a much more succinct version of how we wrapped up here. Here I have essentially the same scene that I was doing with Ben. So we've got our axes setting up a 3D coordinate system. We've got our curves, got 10 of them. Here, when we animate, the curves are getting drawn, the dots are following, and Ben had just asked if we want to have the curves fade out over time. What I should have said is that you just type fade out curves, which is another animation type. It'll slowly change them to have 0 opacity. In this case, that evolution time, if we make it the parameter, the runtime rather, if we make that the parameter of the play argument here, then it becomes a runtime for everything on the inside. So now when we do that, it goes, and over the course of those 10 seconds, the curves should slowly fade, and indeed it looks like they do, and then we're left just with the dots, which is nice. It looks very nice. The other thing that we got into, and I took way longer to say this than I properly should have, because I was trying to remember what the names of the functions were and things like that. Again, I'll post this all in a more uncut version elsewhere. If we wanted a nice effect where there's this sort of tail following the dots that sort of fades out nicely, there's this thing I once wrote for I don't even remember what video way in the past, called tracing tail. And so the way this will work is if you give it just a single little object of some kind. So let's give it that first dot, and then let's add the tail. Then rather than fading out the curves in this case, actually what I'm going to do is just set those curves to be invisible. So set their opacity to be 0. So they'll be drawn. That will determine where the dots go as they're having this kind of update function called on them, but we won't actually see them. What we will see is this one tail for one of the dots, I think. So the way that it looks, great. We see that one little tail, and it kind of fades out in the back. I like the effect. It sort of goes from full opacity to zero opacity, zero stroke width. You can change some of the parameters on it here. So in this case, the amount of time that it follows it. So right here, it's showing kind of the last 1 second. And if we were to wait, it would sort of fade out because 1 more second has passed. So instead, I could say, hey, I want you to follow it for a little bit more time. So let's make that time traced 3 seconds. Instead of just having one tail, we could have a group of them. So we'll create a group of these tails, not just for the 0th dot, but for all of the dots, for dot in dots. And then I could maybe have it match the color of that dot so that we kind of see them all. So now when we do this, we should see 10 different tails all following for a little bit more time, which I think should just give a nice, oh yeah, that gives a nice smooth little effect. And they all start to spread out. You can see that spread really cleanly. And here we can have more fun by basically having it evolve over more time. Instead of 10 seconds, we could bring that up to 30 seconds. We could make them closer. So this epsilon value, instead of being 1/1000th, we could make it, 1/100,000th. So it should take longer for them to all diverge. So now if I go, we see all of those tails. In theory, these 10 dots should actually stay closer for much longer, and it should take longer before we see that divergence in the chaos. And indeed, it takes a little while, but eventually they spread out. So I think that's kind of a nice end effect. Like I said, I'll post the more uncut version, but now is a pretty good point to just jump ahead towards other topics.
Well, goal achieved. You've got a Lorenz attractor with multiple initial conditions, varied very slightly, animating prettily with a glitchy trail. So before we finish the workflow, you've made a code that does a thing, and let's say you're happy with it. I know there's lots of polishing that you want to do, but you then bake it into an MP4 file.
Oh yeah. So in this case, once I have the scene that I like, and so in this case, maybe we'll, I don't know, like clean it a little bit. I might want to render this out. So got a little keyboard shortcut. The way that you might like call Manum usually is like in the command line. If you've downloaded the GitHub and you've imported and all, you say Manum, and then you pass in a file, a Python file that contains the scene.
Yeah.
And so in this case, I found the scene to put that. You say, which scene do you want to render?
From that file.
Yeah. And then in this case, I have a couple different parameters. Like if I say pre-run, it'll go through it all without animating to, one, estimate how long it'll take, and also catch any errors rather than
halfway through the animation.
Yeah. This Finder thing just means it's going to pop it up in Finder, the Mac OS like file system. And then W means write it to file. And so if I run this, it like pre-runs through, thinks about it, it knows how long it'll take now. And now it's rendering it to an MP4. And because I'll usually render it at 4K, sometimes the rendering will take a little longer. One of the reasons I wanted to make any kind of behind the scenes, the way I used to use Manum, and the way I actually suspect a lot of people who use like Manum Community do use it, is you're always running it from the command line.
Yeah.
So you've got your scene, and then you run like Manum, that scene, and then it like pops up. It like renders an MP4 file. So it like has to render the file and then
just plays the video.
And there was a bunch of shortcuts to say, oh, don't render the whole file, just render it starting at this animation or something. But you can imagine the iteration cycle is a little more annoying if every single time you're making an update and you want to see it.
It's rendering out.
So it was later in the game, around the same time I was changing the implementation to run on OpenGL, to then also have kind of the interactive shell version, such that the process of creating just is like highlight the code, see what the code does.
And that's a fundamental change to the workflow in that.
It's huge. Yeah. And my specific workflow, it depends on like these Sublime scripts that I wrote that will send a command to the terminus, which is the extension of Sublime that makes a terminal. So what I'll do is in the description of this video, I'll actually document like what that process is. And so if anyone's curious and wants to replicate it, probably whatever text editor they're using,
you can make a script.
You can do something that does the same. So for all the people who are in like Visual Studio and whatnot, you can do something that would look the same. Okay, so here it rendered it, and then now we have. It's going to look all glitchy because of those glitches that that I mentioned.
But this is now playing in a video player. It's a file.
I would drop into Final Cut, do my editing. I mean, I guess another thing we never did is like we could have the equations. Let's add the equations. So you can have like a LaTeX object that's basically going to say, hey, take some LaTeX and then render it, and then we'll kind of add it on. Have you ever used MathPix?
No.
MathPix is so good. So it's OCR, but for LaTeX. You can take a snapshot of just any equations, and then it gives you all sorts of things. But one of them would be the LaTeX for that expression.
Fantastic.
And so it also gives you it as like an SVG if you want, and all that. It's really good.
So from a screenshot, literally a bitmap is
turned
into a scalable vector.
Flipping heck. It's great. It's so good.
I guess it renders it in LaTeX and then SVGs it out. Yeah.
So we can use this here, so we can have our equations, and then add those. And so
that will dump them in the middle of the screen. Am I right?
You're absolutely right.
Hooray.
So it'll dump them in the middle, and also on the XY
plane. Okay, gotcha. Yeah.
So what you do for this, if there's a 3D scene and you want stuff like that, is you say fix in frame, and then basically it'll, as if it's glued on the camera frame. Yeah. And then in this case, we might want it in a corner. So here's something I wrote, which, let's see if this works actually. So you can index into it by a string. So I can say every time you find an X, maybe color that red.
Oh, that's useful, but not working. Yeah.
Here's a better way to do that. Tech to color, and by better I mean more, it'll actually work. So T to C, I guess is what we call it. So T to C, let me get my line spacing in a way that looks a little bit nicer. Okay, so here's a nice thing you can do. If we say everything that looks like an X, make that red, everything that's Y, I don't know, red, green, blue, let's say. I think that will. And actually, now that it's known to separate those out at some point, if I do, say, equations, and I try to pull out the X's, and I don't know, I like shift them a little bit up,
you can
then it has control on them. It does its best if you don't do anything to like say, hey, these are specific variables I'm going to want to separate. But you have to like, from the tech expression, know how many symbols there will be such that it can dissect the Manim object in there
into the right number of.
It's a little tricky to get it to actually work. So if you know you want control over variables, you just put them in an expression like this, or there's another one called isolate or something.
Great.
9 times out of 10, it'll work by default anyway for like simpler expressions. Maybe you do something where it's like we're gonna write the equations onto the screen to just like be Manim about it, and then now that's going to be the scene that renders if we go, and then it does its whole thing. And so those are just up there as it's doing its thing.
And are they behind or in front of the camera? That's the sort of thing I'm sure you can control, right? But it looks like they're behind.
Yeah. So in this case, by default, things will just be rendered in the order that you put them on, unless you tell them to apply a depth test. So a lot of 3D objects that know they're supposed to be in 3 dimensions, it's going to be depth tested. In this case, its actual position in like space is on that XY plane, and so it's a little bit weird. But if we wanted them to be rendered, wanted to make sure they show up in front, what we could do is just make sure that we add it down here. And then what I could do, we could maybe say, hey, let's take those equations, and I want to set like a backstroke so that there's a little bit of like
frame
spacing around them. Let's maybe make the font size a little smaller so that they're just up in the corner. So the font size is like 30, something like that. We put that on, they're a little bit smaller up there. And then now when we render our, I guess they're not really going to overlap with the solutions because I made them smaller.
But if they did, we'd see them in front because they're being updated every frame. Isn't it?
Yeah.
Being able to break the text into sort of mathematical parts is extraordinarily useful if you want to highlight mathematical parts. And it's something that would be a real pain to do in any other context.
Yeah, here, you know what I maybe should say? I have some example scenes basically. So this is my intention. Hey, if you wanted to get started, just look at a couple of these examples. And so if you wanted to see like working with some tech, what that might look like. In this case, I've got actually a series of expressions that we're going to play with, which is basically rearranging a certain equation. And these are going to be the lines of our equation. And now it's just rendering the first of those lines. I've got a special notion of transform that'll try to match the strings underlying it, so that if we play like this, the a squared goes to the a squared, the b squared goes to the b squared, and things like that. There's example scenes in here to kind of show the kinds of operations available. If you just play around with some strings, this like matching string will automatically give you a nice anagram animator, where you don't even have to think.
You don't have to worry about it.
Don't have to think. It's just like move the letter to the corresponding letter, and like it's sort of a one-liner that does that. That was like an emergent thing.
I mean, slightly not helpful for viewers, but we saw a big anagram discussed
a
couple of days ago. We should tell Simon.
This would have saved Simon if he had run it through Manum. I can just like show a little bit more in here if you want, where got this equation, famous equation. If you wanted to say, hey, I just want to reference the E part of that, there's an animation called flash around, and you'd be flashing around just that E. Or there's another one called indicate, and you want to like indicate that pi. Things like that. So you're pulling it out bit by bit.
And in terms of understanding what functions like that exist, obviously there's your head, which is this vast trove of experience over the time you wrote it. But the Manum Community version is a different version, but these still exist.
Yeah, Manum Community definitely has much better documentation. There's not zero documentation on this one. You can see all the animations basically in a folder of the library called animation.
Yeah.
If you just like look through that folder, you'll see the things that exist. All of the code I've ever written for any video is on GitHub. If you
really,
yeah. So if you go to github/3b1b/videos, this GitHub basically has all the animation from like videos in the past. So in this case, I guess, and videos of the present. I haven't made any animation for holograms yet, so that one. But you can see some puzzles that I just made for the IMO. You can see it all in there, and then that gives you some sense of what the functionality available is.
And maybe this is a workflow thing for people like me who are beginning. If you don't know what functions are out there, obviously you can look at the library and see what's in there. There's no autocomplete sort of like if you start typing one that you think might be it, you can't.
Oh yeah, sure there is. I mean, there's all sorts of autocomplete tools out there,
which we more to do with the text editor.
Yeah, so this is a text editor question. So like in Sublime, there's like a thing called a language server protocol, and so there's some. I think it's called like Pi LSP or something. But as it
they're all there.
You know, it has some sense of the environment that it's in and might auto.
Okay, so that's one way to find a function that you think, I want. If I was going to write a function, I might call it this. You can find out if there is one called that.
GitHub Copilot, right? Just like use Copilot. Okay. I don't like using Copilot with Manum just because, like, I know what I want to do, and it doesn't quite know what I want to do. And it's really nice if you're like engaging with a new library of code, but I don't know. I just find like dumber autocomplete tools to be the thing I actually want, because often it's like it's not a. If I don't know exactly what I want, the way I want to even articulate the request is in code, not in English.
Yeah.
And to each their own, but like just try it.
Yeah, and you have the experience to sort of fall back on your experience.
Yeah.
That's good.
Yeah, just fill it in.
No, but that is a sort of workflow thing, and depending on your text editor, and it's actually something I'm just not used to. Like it's that lower level sometimes that's the barrier to getting started in these things. Like, but once you cross those first hurdles,
how do you even know where to start? Yeah. So the example scenes, I think, would maybe you know, gives you some sense of it. But.
Nice. Well, thank you for showing me. I really enjoyed seeing the back end. Like, it's a very human experience coding, and the messiness is part of it. Isn't it?
So there you go, little peek behind the scenes. I will leave a link in the description to that repo where you can see the code for literally any video I've made in the past. By the time I post this, I'll also add something to the README of that repo to outline the actual workflow that I'm using here, you know, the specific Sublime scripts, what you would want to mimic if you're using a different text editor, things like that. And I'll also post the full version of that conversation, warts and all, to Patreon. I might actually do some like Manum live streams or something like that on Patreon periodically. If that's a thing you would be into, let me know. If so, what kinds of things would you like to see? But in the meantime, I'll be busy animating the next video, and I will see you then.